So we understand from various industry sources that SQL injection is the most used of all the attacks. We would like to talk about how they can be initiated, how they can cause damage or loss, and how you may prevent against such attacks. So we will also discuss detection tools and how to prevent such attacks there.
Yes. Any security breach might result in giving access to sensitive information, such as social security numbers, credit card data, financial information, and user IDs and passwords. A SQL injection, when successful, can give access to the data with privileges to create, read, update, alter, delete, and/or steal data from the database. The main source for such an exploit is the source application or the web server, not the database or the database server. So a vulnerability in an application can cause a SQL injection attack.
Yeah, that's right. And an attacker can manipulate and submit a SQL command to retrieve the database information or gain unauthorized access to the SQL server. This type of attack happens mostly when the web application executes by using user input without the proper validations. Happens all the time. Most times we don't encode the data, so it is much easier for the attackers to inject malicious SQL code and steal the data. So the user data might contain SQL statements with malicious intent. So we just mentioned that the main source of the attack is the application. But what does this mean? It is through the inputs you provide without proper validations.
That's correct. We're just going to briefly mention the characters used by attackers. They try to make use of the single line and multi-line comments and string indicators, such as OR. They can use concatenation characters, wildcard parameters, URL parameters, local and global variables, time delays, and a whole bunch more.
Right.
They will have a host of things available at their disposal. As a programmer, you will need to handle these characters while processing in your program. As a tester, you will need to consider this while testing to identify any vulnerabilities.
Right. And you are aware that applications implement authentication mechanism. This varies from simple to complex mechanisms. So what happens is attackers will understand these mechanisms, obviously, very well. They use sophisticated evasion techniques to bypass user authentication. They make use of the issue in using OR to evade advanced systems that verify signatures. So attackers also use hex coding. You are aware that hex coding is used to represent URLs. You would have noticed some URLs having %20, %20. That's the hex encoding. It is used as a single space. Most alphanumeric characters use hex encodings, but many intrusion detection systems don't recognize hex encodings. This feature is utilized by attackers. It's a very powerful way to attack as hex coding obfuscates each URL. And this can be done in many, many ways.
Yes. And today's signature-based SQL injection detection engines can detect attacks related to changes in the number and encoding of what it's called white spaces around malicious SQL code. However, they may not be able to handle white spaces around the same code. They also fail to detect the same kind of text without spaces. Attackers normally remove white spaces from the query. So the attacker obfuscates input strings by dropping or adding white spaces between the SQL keyword and string or number literals without altering the execution or SQL statements.
That's right. And so if you add white spaces using special characters, things like tab, carriage return, line feeds, the SQL statement becomes completely untraceable. However, the execution of the statement itself will not change. So dropping spaces from SQL statements will not affect its execution by some of the SQL databases.
And we mentioned that you can evade signatures that filter white spaces. You can replace white spaces between SQL keywords with inline comments. /* and */ can be used to delimit multi-row comments. This allows the spreading of injection command through multiple fields. To evade IDS, IPS, attackers use the char function to inject SQL injection statements arguments into my SQL without using double quotes.
Yeah, a SQL engine builds a single string from multiple pieces, so the attacker has the help of the concatenation operator. Now, the keywords are broken up to evade identification intrusion detection systems, as you can well imagine. Concatenation syntaxes may vary from database to database. Attackers obfuscate code to evade detection by the intrusion detection system.